is. All right, so we're talking about the importance of unit testing, and it's a hot topic, and we'll dive into exactly why it's useful. I'm Mike Decker. I'm a senior web developer with Stanford Web Services. You can reach me at Pookmish on Drupal.org, GitHub, pretty much anywhere that there's an account that's Pookmish. That's 99% likely that's me. So I'm very active on Drupal.org. I'm very responsive. Same with GitHub. I like to contribute as much as I can anywhere that I can. So let's take a look at what is unit testing. Unit testing is really the simplest form of testing any development code. It's really fine-tuning and getting down to the very nitty-gritty of the code and testing. This is supposed to give me this result. And it's independent of every other code. So if you have 20 different classes within your project, it's really just testing one particular part of one particular class. It has no dependency or relation to any other development code within any other project, maybe an open source contrib dependency or any of that stuff. It's just testing that little specific thing. And it's testing specific functions, methods, or an entire class or object. So it's not testing the actual implementation with integration with all of the other contrib and open source solutions. It's just testing, well, what does this function do? What does this method do? Or does this class or object give me the desired result? And one of the really big things about unit testing is it can be automated. A lot of times it's ran manually, but the more frequent and more tests that you build out, the more useful automated testing becomes. There's several testing infrastructures out there: Circle CI, Travis. There's GitHub Actions. All these different type of automation tools that make these type of functions and unit testing very easy to manage and run. And then they produce GitHub pull requests that show status updates if a test has failed or if it's successful. You can go in there and take a look and approve and see where the actual changes are breaking down. Now, unit testing, because it doesn't rely on any external sources, any external dependencies, there's the potential need to require mocking dependencies, such as your API calls. This object might require another object or another service somewhere in the contrib space or open source space. And because we don't want to specifically test those particular parts, we have to mock the actual functionality of that dependency, and that just kind of simulates the reaction or the response from that dependency. And we'll take a look at an example of a mock dependency here in just a couple moments. So with unit testing, there's a whole lot of different frameworks. Some of the most common frameworks are PHP Unit for PHP. There's Jest for unit testing JavaScript code. And then there's JUnit, which is very popular within Java unit testing. And there's hundreds of more different frameworks out there. There's some for C#, C++. I mean, the list just goes on and on. And a really great thing about the unit testing is that they can actually produce coverage reports. This is certainly a hot topic even when you get into the unit testing. How much beneficial is a coverage report? That's very subjective to the actual scenario, but it's certainly a benefit when it comes to actual unit testing. You get those coverage reports, you can see where your testing is actually being done. So let's take a look at, here's an example of what an actual unit testing, like I said, is the very most simple level of testing before it gets to the integration or systems or acceptance testing. It's just testing the individual portion. And the higher you go on this scale towards acceptance testing, the slower the test runs, the more dependencies and the more essentially booting up the entire system is required, because when you get to acceptance testing, you're actually testing the user interface and how it functions. A step down from that, you're testing the system, making sure that the database is set up correctly, or different things like that. And the further down you go, the more simple it goes. So it's actually really easy to build out unit testing at the most simple level without the additional overhead of the acceptance testing. So now there's this myth: I don't have time to write tests. It's such a myth. It does take time to learn how to write tests, and getting up to speed with unit testing or even acceptance testing or any of that kind of framework, it's going to require some legwork to get to the point where you feel comfortable of building out unit tests. But if you just start to kind of wrap that in with the estimates necessary to actually build out new development, it becomes a lot easier. Let's say you think that it's going to take you 6 hours to build out the necessary functionality. Pad your little bit extra time to give yourself that ability to write those tests. Instead of saying, well, I estimate this is going to be 6 hours. Give yourself an extra few hours, especially in the early stages of your testing exploration. Give yourself 10 hours, maybe 12 hours to build out those tests and give yourself some time to actually build those out. You can see over on the right this this little flow chart. The more pressure you feel to actually produce a particular new development, new feature, you're going to write less tests, and then your code becomes less stable, and it's going to break down. You're going to have more bugs, and you become less productive because you're having to fix those bugs retroactively instead of proactively. And then that puts more pressure on you with the new code, and it just becomes a very repetitive cycle. So, building out those tests up front is going to be huge. Now, establishing a testing requirement for new code. My team with Stanford Web Services, we have a couple of requirements that the code coverage must be at least 90%. And that the test must satisfy the most common scenarios. Now, you're never going to be able to produce tests that are going to cover every possible scenario. It's just impossible to think about that. But if you build out tests in the most common scenarios, you can come back to them when you find a bug. Maybe it's a less distracting bug, and you can come back to it at a later time, or maybe it's a critical bug you have to implement immediately. It's easier to tweak the test and satisfy that new bug if you already have the test already pre-written. Now, it's like I mentioned earlier, it doesn't replace integration or acceptance testing. It's just helpful to kind of build those building blocks for the reliable code. And a small amount of time up front will save you a lot of time in the long run. There's several studies out there that have shown that the more testing you do, the more money you save in the long run, because you do the legwork up front to actually produce those tests and produce more reliable code. Now let's take a look at what a unit test actually does. This is the absolute most simplest form of a unit test. On the left, we have a basic class that just has a public function, and on the right we have the test. So I'm constructing the class. Of course, this is PHP, just in case you weren't familiar, and we're essentially asserting that what the class returns is going to be what we expect it to be. Now, this class might call other classes, or might call other methods within the class, or it might do some computation, addition, manipulation of data. We essentially want to check what that method is doing, so that it's producing the desired result. And like I said, this is the most simplest form that you can possibly get with a unit test. Okay. Now, earlier I mentioned mock dependencies. They simulate the objects or APIs from external dependencies or open source solutions. They are going to be very essential because almost none of our code is self-contained. It always relies on external dependencies. And this like I mentioned, it assumes reliability on the dependency. One of the nice things is, by mocking a dependency is if you have a particular bit of code that's calling an API, a lot of APIs nowadays have rate limiting or pay per use service, such as, you pay for a certain amount of API calls. By mocking the dependency, you're not actually calling the API, and so it prevents those rate limits, reducing the potential for any kind of overage usage or increase in your billing for those APIs. And a downside with mock dependencies, it's pretty challenging to establish and build out a very large mocked object. There's a lot of tools out there. PHP Unit uses mock objects in a very useful way, but if your class is calling the methods on an object, like it's calling, let's say, 10 methods on an external object, you're going to have to mock up every single one of those 10 different methods so that the mock object is returning the response that you would expect from that mock object. So it does take quite a bit of kind of scaffolding in establishing that mock object, but then once you kind of get in a role, it becomes pretty easy. So here's an example of a mock dependency or a mock object. For this particular scenario, we're using Guzzle to mock a response from an API, and this is using PHP Unit framework. So there's some very nice methods that come with PHP Unit, such as create mock. You just give it the interface name, and it'll create a mock object for that with all the necessary methods available to it. And with Guzzle, there's you do a call, and then you get then there's a response, and I'm sorry, I stepped down a little bit. So here's the actual Guzzle object itself. And what it's going to do is on the request method, it's going to return the Guzzle response. And up here is the Guzzle response with a mock response of get body is going to return a JSON data set. And so this allows us to kind of simulate the API. APIs have a known schema. They're pretty well established. And you can also mock failures, such as if the API is down, you want to test for a 500 error or a 403 error, or these different type of scenarios. You can mock a response so that the functionality that you're building can withstand any unknown scenario from the API. So, okay, so we talked about a little bit about what is unit testing, what is mock objects, but why is it so important? It's going to find bugs earlier on in the development process. I can't tell you how many times I've built out a unit test, and there's a variable that, maybe it's an array that doesn't have a necessary key. Providing the error handling functionality to check for that particular key of an array or this value of an object is going to be critical for withstanding any possible scenario that could be thrown at your code. Then there's the scenario of API upgrades and versioned URLs. I have an example coming up in just a couple minutes about this exact scenario. APIs typically version 1, version 2, etc. And their schema changes. And so you want to be able to call that API and get an expected response. And unit testing makes that possible because you can use that mock object that we talked about, mock the API response from version 1 to version 2, and then just you refactor your code to make sure that it still passes the given scenario. Unit testing is also really helpful for reliability and repeatable scenarios. For long-term products, long-term maintainability, making these repeatable scenarios is key, because if a user gives you a bug report, you can repeat that scenario, build out a test, and essentially you write a test for that particular scenario. The test will fail, and then you adjust your code to make sure that the test passes and all the other tests pass. So that's really the repeatable scenarios is key. Now, unit testing increases confidence and stability when refactoring. We always go through life cycles with software development where 6 months, maybe a year, maybe a couple years down the road, we come back to the code that we wrote or somebody else wrote, or something that we've been handed off, and it's just not quite up to standards, or it's not really using the most performant method possible. Maybe there's a different solution out there that we can take advantage of now. We're always going to be refactoring our code, and having these unit tests ensure that even if you refactor it, it's still going to give you the expected result. Maybe you're changing an underlying dependency from, maybe you're going from traditional curl requests in PHP to guzzle. You can do that type of refactoring and maintain your unit testing without any kind of concern. And tests can be expanded when a bug is discovered. I talked about this just a moment ago. You build out a test for this scenario, the test is going to fail, and then you address the code to satisfy the test, as well as all the other tests. And refactoring and ensure compatibility. I just mentioned about this. Whenever we refactor and change our dependencies, it might be necessary to ensure the stability. So now let's take a look at a real-world example. This is using our Stanford Simple SAML PHP. It's essentially a Drupal module that builds upon the Drupal Simple SAML module that's in the contrib space. It adds a little bit of additional flavor for us, and it provides a connection to what we call Workgroup API. We have a way that when a user logs in, it checks if the user is part of a work group, and if it is, give them an appropriate role as configured through the UI. And recently, we went through an API version change. We went from API version 1 to API version 2, and it was very different. First of all, the data system was completely different. It was an XML in version 1. Version 2 is now JSON API. Version 1, we had to make an API call to check the work group to see if a user was in it. In version 2, we call the user to see what work groups they have. So it's a very, very different kind of system that we needed to account for. So if we take a look at this, let's take a look at the actual code here. Okay, so this is the old version, and if we take a look down, here is the guzzle callback. This is essentially the data that is being returned from the mock API that I talked about earlier. We have an XML data set returning an expected kind of data set of the user's name, and this is considering the URL with the work group that I mentioned just a moment ago, where we're calling the work group and getting a list of the users instead of calling the user and get a list of their work group. So it's completely opposite. Now, if we take a look at the most recent change, let's take a look down here. Where are we changing? My apologies. Okay, so here's a particular response where we're changing from the XML to a JSON data set. And we changed the guzzle callback data that's being returned, but we don't really have to change anything else within the text. You can see here, I just manipulated a little bit of the way that it's testing, but the actual test itself is still testing for the exact same data, and still testing for the exact same response from our service after it receives that data from the API. So being able to produce these unit tests in a way that you can just tweak the test a little bit and then manipulate your code and refactor your code to satisfy the test is really critical, and it's going to be really long-term beneficial for any product and any user-facing service. Cool. So now let's open it up to questions. I know we're a little bit close to the top of the time, but is there any questions out there?
Question from Bernardo. Resources, books.
Resources and books. PHP Unit has a really great resource. Their website has a lot of examples and resources to build out PHP Unit testing. As far as Jest, I know that there's several blog posts out there in the space. My colleague Jen, that's on the call here with us, she's actually been experimenting with Jest a little bit as well. As far as books, I'm not immediately aware of anything off the top of my head. I'm not really a book guy myself, so.
Any workshops? Thank you, great presentation, both highlighting the importance of unit testing and showing it in the case. So thank you very much.
I actually have a quick question, Mike. You talk about like covering common scenarios and how you can't cover everything and how it's just like a basic function or method test that you're doing. Like, how do you figure out what is the outcome you want to test? Because, you do a stack trace and everything's going through like 20, 30 functions and methods.
Are you talking about like when you encounter a bug? Is that?
No, just in terms of like how you go about deciding where you want to test, like what layer of the code or what the outcome is or outcomes are that you want tested.
Well, I mean, if I'm testing for manipulating an array, I'll test for maybe I'm changing, I'm concatenating first name and a last name portion of an array. I'll test for that particular scenario. Maybe foo and bar gets concatenated to foo space bar or bar comma foo. That's going to be the most common scenario. But then maybe down the road, you encounter a scenario where the first name doesn't exist, and so your array is just the last name, and you didn't account for that in the previous in your general kind of initial attempt, and that's going to be common for anything that we do. Maybe an API call, instead of giving a 500 or a 403 error, perhaps there's it produces a 200 error, but the data is empty. That's something that we've actually had recently, where the API call says, yeah, it's a valid response, but it's not it contains no data. It's just completely an empty response. And it's something that you're not going to account for until you actually encounter it.
Cool. Thanks. That was great. It was great, by the way. Learned a lot.
Cool, thank you.
Well, Mike, thank you very much. Excellent presentation. Thank you. We have 10 minutes for, happy hour, happy 10 minutes, happy 5 minutes. Or we can give everyone a Zoom break, and looking forward to seeing folks hopefully in person someday. resolve it.
Cool. Excellent. Well, I appreciate everybody attending, and you know, I mentioned, my username is Pookmish on pretty much anywhere. A little backstory: it's just a random name that when I was creating one of my first email accounts back in the day in high school. So yeah, reach out if you have any questions on unit testing. It's really helpful, really beneficial. It's caught our team at Stanford Web Services dozens, if not more times than, you know, it saved our butts several times. So Ian and Shay will contest to that. Excellent. Well, thank you so much. Appreciate it.
Thank you. Well, Mike, thank you again. It's been great, and looking